Hello, everybody, and welcome back to video 39 in this set. Preparing some lecture notes and using videos to help uh, edit my way through them, and decided to, instead of deleting the videos after I get my lecture notes edited, I will go ahead and uh, share them on YouTube. And as far as the original plan of getting ready for a summer camp with high schoolers, I think this is going to be a little bit long. I'll need a smaller game, but I want to hit some key points here. If you've been following along the videos, hope you've noticed we've talked about a lot of stuff, not just the raw code like we would see in a tutorial, but the concepts, storytelling, that's a big one. A few puzzle games are able to get away without a story, but we almost always want to include that. And that's something I've seen a number of times in game development classes is people try to just move the graphics and think that's enough. But uh, what they're overlooking is they do have a story. They know why they're moving and where they're moving those graphics to. So we have to actually tell the story with that game to keep it, make sure it's known what's going on with it. Um, Try to talk about a bunch of the concepts here. And this next one, this should be a fairly short video. I just want to fix something we did earlier. So if I give this a quick run, um, this is just a rough draft. That was one of my tips is always get a rough draft of all the major pieces at least working and then come back and clean it up. It's a lot easier to clean up afterwards because even if you try to focus on all the details along the way through, you're still going to have stuff to clean up afterwards anyway. And it's a lot easier to do the cleanup when you have an entire game. So that's just something I found of uh, after years of making games and trying it both ways. Uh-oh, the sun went down on me. Um, Let me pause the video till the light's back again. Okay, I talked for a little bit too long there, but the next one is something kind of related to this. Other knowledge we want to think about, and this is one that's often overlooked. When I hit the character, right now we have that little animation that just rotates 90 degrees, which doesn't work very well on a hillside, and I was thinking clean that up later. But I think I want to do something with it. I think I'd like to make it look like we really hit the character. When we hit the character, he goes flying off and spinning off to the side. Someone to write some code that would do that, which is another thing that was going to be very abbreviated in the lecture notes, and I'll probably put um, a very short video together. But that has to do with physics, and that's another thing. It's That's what we're trying to simulate when we write a game like this. Is even if it's very loose with the physics and not complete realism, we're still trying to simulate or replicate roughly the laws of physics. And that's kind of hard to do if you don't know the laws of physics, if you've never done any study of physics. So that's another one that, just like storytelling, it's an important part of the game. It's something you want to know. For a more generalized example, because sometimes people overlook that in video games for some reason, game development people seem to come with a different approach. But to tie it into like business software, uh, how could you write accounting software if you don't know anything about accounting? And that's kind of how storytelling and physics fall into game development. Yeah, a lot of people try to come into game development without knowing anything about physics or have any good structure for storytelling, unless it just happens to be a story that flows out on its own, and expecting to be able to tell a story and simulate the laws of physics. So there is some other knowledge that pertains to game development. Um, I guess it's kind of subtle in these videos, but like that's why I'm able to do so much without looking it up. I've noticed another thing. That's another thing I've noticed is a lot of people have to basically look up almost every step, even things they've done before. All I ever usually look up is the basic syntax, and well, like in these videos, I looked up the basic syntax for Godot scripting a while ago. Saw the latest, saw listed the latest updates for Godot 4 on that, and from that knowledge, I'm refiguring out the logic, and I've basically been making it up as these videos go together. So it's that's the approach you need to have when you're ready to fully make games, when you don't really have to look stuff up anymore. You want to make that the goal. So make sure when you look things up, you're learning the right thing. One of the tips I gave before was with documentation. Always look at official documentation first. That's the user manual. That tells the whole picture. Tutorials only give you the first step. That documentation isn't going to make a lick of sense at first. But instead of going to a tutorial and learning how to do that one function, look at the documentation, go to the tutorial, and then use the tutorial to learn to read the user manual. And then you'll be able to do basically anything without having to rely on looking up a tutorial to copy off of. But this thing, the sort of replicative physics, instead of our alien just falling down, rotating by 90 degrees, that we did here, let's set it up so that he starts spinning and goes flying off the scene so it looks like we hit him really good. And that'll be a better animation. I was thinking a better indication that the hit was made. And something else you're hopefully noticing if you've gotten this far in the videos is this will all use things that we've seen before, just a new combination of the tools we've already seen before. That's, I guess that's what I was trying to get at a moment ago, saying I learned the basic syntax, and then just from years and years and years of practice of programming, I can figure out different ways to put those tools together to get new functionality as needed. That's what you want to practice on. Don't look for one particular method and think overall about what it's doing. Think about the little pieces, not the overall action of what you get from those pieces together. And then you'll understand how to put those pieces together in a different order to get a different result the next time. So first thing I was thinking is, well, put a bunch of those little pieces together and let's make a function for when the alien gets hit or got hit. I think I'll use this to deactivate it. So we'll say active equals to false at this point. And then to make him spin to rotate, that's going to happen every frame of the game. So I'm going to set up a Boolean. I'm going to come up here, create another Boolean. I'll call it flipping. It's going to be Boolean, and at first it's set to false. And after we do all this stuff, it won't be active anymore, so we'll have to check at this point. So if flipping, and then we'll come back and do that in just a moment. And when we get hit, we'll set flipping equal to true. Notice how I'm bouncing around in the code. That's something else I've found over the years. I probably could have explicitly stated it before now. The code has to be in a certain order for the computer in the end, but that's probably not the order we think about things in. And it can be a lot more productive to bounce around. We can put our cursor anywhere in the text file. Just bounce around and put the code together in the order we think about it in, instead of trying to do it in the order the computer needs it in to begin with. So we'll start flipping, and we'll do that for a short amount of time. So that means we probably need another counter. So I'll come up here and copy this counter, paste that in there and give it a different name, maybe deactivate. Deactivate, if I can spell that correctly. Or it doesn't matter if it's spelled correctly as long as I spell it the same way every time, right? Deactivate, and I'll just copy and paste the previous counter, so no new logic there, and then I'll make a new method called remove alien that will get rid of this after it's done. And maybe this needs to be a little bit longer. Let's see what 1.3 seconds is. We'll hit our alien, he'll go flipping off in the distance for 1.3 seconds, and then we'll remove him. Function remove, oh, that's on the clipboard, isn't it? Remove alien, and we'll get to that in a second. So whenever this is true, whenever we start flipping, then we want to start that counter. Deactivate.start. So we'll start our counter, and then we'll start flipping off in the distance, and that's something we've seen before. That's just our rotation. So our rotation, um, I'm thinking sideways from the way the animation went, so I'll rotate around the Z axis is the rotation.z and degrees to radians. Let's see what happens if we rotate 10 degrees, and maybe that needs to be negative. It's got to be either negative or positive, so I'm just going to take a guess and see if that's backwards. And at the same time, position, well, the nature of the game, we have to sneak up behind our alien, so it's probably going to go in its forward direction. So I'll change its position to whatever it was, plus maybe I'll do 3 times delta, see what that is. So I want it spinning really fast. So I'm not going to multiply by delta here. Might need to adjust that. We'll see what it looks like. And then we'll head off in some direction. So sort of the laws of physics, like if we get hit, we're going to go flipping off to the side and fly forward. And just replicating that. And when that deactivate timer runs down in the remove alien one, we want to actually stop processing for that, right? We don't want it sitting around wasting RAM and GPU resources because it's going to be finished with our game. And I guess this is new. So to remove something, to completely delete it out of memory, we're done with it. We're never going to use this alien object again. GDScript is based off Python, so we have the keyword self to refer to the thing we're creating. And we can just call this queue free. So just free up the queue, all the stuff in the queue, and that will remove our thing from memory. Hopefully that's a little bit better than just knocking it over. So instead of changing the rotation, I'm just going to call this function, and that should handle all of it. Where was that at? Oh, there it is. So even highlighted. So instead of changing the rotation, I'm just going to call that got hit function. And that should be enough. We're on level 1, so if we give it a run, hopefully this will give us a much better something much better replication of the physical processes that would happen if we came up and hit our character really hard with a stick. Looked like that rotation was backwards, so let me switch that to negative. On the alien script, switch that to negative and give that a run. So sneak up behind them. Whoops. And when we hit him, yeah, then that looked like got hit in the head, went flipping off in space, and it just deletes after a couple seconds. So just a slightly better indication of that. I just wanted to talk about a couple of those points. The storytelling, we want to make it look real, and storytelling and simulating the laws of physics are what we're doing. This video included both of them, and when you're following along examples and looking things up and along the way of learning, make sure you're breaking it down to the smallest pieces. So not the overall process here, right? That's spread all over the script, actually spread all over a couple of scripts. But what does each individual line do? And that way, the next time you need something that does that one instruction, you know how to replicate it and put those instructions together in a different order to fit your need. That's what you want to work at. You don't want to do an exact copy of the things you see. Make sure you're making sense of it so you can start doing your own thing as soon as possible. And that was all I wanted to talk about in this video. So I will see you in the next video.